So, despite the Apollo moon hoax, there are people who still believe that man is in space, and we have all sorts of space vehicles and satellites and space stations up there. It's time to have a look at the space shuttle. So, let's take a look at a typical shuttle launch.
T-minus 17 seconds and count. 15, 12, 11, 10, 9, 8, 7, 6, start, 2, 1, booster ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
Now, I'd like to stop it there for a moment because I'd like to draw your attention to the shuttle's trajectory. Now, as a kid, I often wondered why it was that all rockets and space shuttle launches, they never ever went straight up. They always curved off to one side. Now, I remember being told at the time that it's because the Earth is spinning and the rocket is actually still going straight up, but from our point of view, we're just spinning away from it, so it looks curved. Well, you can't have it both ways. If that's the case, then when we jump into the air, we should land about a kilometre to the west. So you can't have it both ways. The quickest way into orbit would be straight up. Going horizontal would be the long way round. Let's continue.
Standing by for the throttle up call from Capcom Steve Pro.
Okay, at this point, the shuttle is horizontal. That is, it's not getting any higher, it's simply travelling horizontally along the ground. And as you'll see in a few seconds, when the booster rockets separate, they still fall to the ground under the influence of so-called gravity.
Discovery, you can go and throttle up.
Roger, go and throttle up. Throttle up.
Throttle up, throttle down, like Commander Steve Lindsay.
Expected to hit middle clear shortly.
Copy.
Solid rocket booster separation confirmed. Guidance now converging. Discovery's onboard computers commanding the main engine nozzles to swivel, aiming the shuttle for its precise target in space for main engine cutoff.
Should have a good forward leg now at S10.
Okay, you sound good.
Discovery Houston, negative return.
Copy, a negative return.
So, ground-based video ends there. Not because the shuttle's too high, but because it's too far away downrange. As I said, it's travelling horizontally at this point. So what's missing is what they call MECO, main engine cutoff. That means the shuttle no longer has any power behind it whatsoever. But after MECO is the external tank separation. As you can see from this diagram, when the tank separates, it falls back to Earth. So what's stopping the space shuttle following the same exact trajectory? Between main engine cutoff and this ohms burn, the space shuttle should follow the exact same trajectory as the external tank. But it magically does not. And conveniently, there's no video cameras to show exactly what happens. The point here is that at external tank separation, Both the shuttle and the external tank are subject to this so-called force of gravity. Neither the shuttle or the external tank are in space. And yet they want us to believe that there is an orbital manoeuvring system which is capable of blasting the shuttle from this point, which is still in the Earth's atmosphere, into orbit. Well, the clue is in the name of the thing. Orbital manoeuvring system, not orbital insertion system. Where's the fuel for this? There isn't an external tank anymore, so there isn't enough fuel to blast this shuttle into orbit, even from this height. And on the subject of height, where does space actually begin? In this shot, the space shuttle is supposedly in space, because the cargo bay doors are open. But you can see the features on the ground in great detail. In fact, you'd be hard-pressed to see such detail from a passenger jet at 35,000 feet. Look, you can see roads and rivers and individual fields. Anyway, once the shuttle's completed its mission, it's now a glider. So let's have a look at a video of a glider landing. Now let's take a look at NASA's glider landing, and pay particular attention to the sound of non-existent jet engines powering down after landing.
Down and locked. Main gear touchdown. Nose gear touchdown. Deploying of the drag chute delayed to assess the conditions of the crosswinds on the orbiter as it rolls out on the runway 15 at the Kennedy Space Center, wrapping up a nearly 5.3 million mile mission. Endeavour returning the first educator mission specialist Barbara Morgan to Earth to begin the next step in her journey to inspire future generations to explore, learn, and build a better future.
Houston, Endeavour, wheel stop.
Roger, wheel stop, Endeavour. Congratulations.
Undoubtedly, the nice woman from NASA, employed to state the bleeding obvious, is there to distract you from the fact that it's a bloody jet plane, tarted up to look like a space shuttle. It's not a glider at all. You can clearly hear the jet engines powering down. When you look at the back of the space shuttle, you can see two odd-shaped pods. These are supposedly the orbital manoeuvring system. On the front of these pods are two odd-shaped holes. Why would a rocket engine need some kind of air intake? Wouldn't it be dangerous to put such air intakes on the back of a shuttle, which on takeoff is going over 10,000 miles an hour? Wouldn't they just rip right off? Very strange. No, these holes are precisely what you'd have if you wanted to hide an air intake to a jet engine. So here's a conspiracy theory. If I was on the receiving end of upwards of 200 billion of taxpayers' money, perhaps this is what I would do. I'd spend a few million on some of what they call hero models. Space shuttle mock-ups that look the part, have lots of flashing lights and computer screens and stuff, but are not flyable. They'll end up collecting dust in museums anyway. Then I would have a few mock-ups that I would fly into space, but really would basically fly out of sight and ditch in the sea, getting destroyed in the process. Then I would spend a few million, perhaps even $1 billion, let's give the taxpayers their money's worth. Perhaps I'll spend $1 billion or so on developing a plane that looks like the space shuttle. There you go, job done. No refunds. So let's change the launch profile of the space shuttle for my new classified one. We have a remote-controlled, full-size mock-up, basically nothing inside, just an empty shell. That's flown up on remote control, on essentially a big firework. Everything acts as normal. The booster rockets detach as normal. But when we get to the external tank separation, that doesn't actually happen. What actually happens is the tank and the shuttle fall back to Earth, where they ditch in the sea and get destroyed in the process. After the mission's complete, a space shuttle plane takes off from an undisclosed location and lands at an Air Force base in front of the TV cameras. Simple. Don't be ridiculous, Dave. You couldn't fake something like that. There'd be too many people involved, and the truth is bound to get out. Blam, 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 blam. The best example of space shuttle fakery is the Challenger disaster. In 1986, the shuttle Challenger exploded about 74 seconds after takeoff, killing all 7 astronauts inside. Or did it? It turns out that 6 of the 7 are still alive and kicking today. Ellison Onizuka claims to be his identical twin brother, Claude. Yeah, I've got an identical twin brother, Claude, too. The Challenger pilot, Mickey Smith, hasn't even bothered changing his name. He's now Professor Michael J. Smith of University of Wisconsin. Now, Krista McAuliffe was a bit of a sneaky one. She was the Challenger payload specialist, quite famous for being a teacher. It turns out during her astronaut days she was using her middle name, Krista, and now she goes by her first name, Sharon, and she's a Syracuse law professor. The Challenger commander, Francis Richard Scobie, is now Dick Scobie, which sounds like a rather unpleasant disease, CEO of Cows in Trees Limited. Judith Resnick, the Challenger mission specialist, again hasn't even bothered changing her name. She's a professor at Yale Law. And finally, Ronald McNair, another Challenger mission specialist, claims to be his identical twin brother, Carl McNair. What are the odds? And now we come to the imaginings of this man here. Arthur C. Clarke, Freemason and science fiction writer, came up with the concept of the telecommunications satellite. And several years later, we have thousands of telecommunications satellites supposedly spinning around the planet. Again, though, strangely enough, if you try and look for images of communication satellites, despite the fact that there are thousands of these things up there, you don't actually find a photograph of them. Just lots and lots of CGI photoshopped images. The problem is that satellites inhabit a region of the upper atmosphere known as the thermosphere. It gets its name because the temperatures up there reach something in the order of 2,500 degrees centigrade. This is a source of some confusion. Although Wikipedia says that it reaches such high temperatures, it also says, paradoxically, that you wouldn't actually feel the heat because there's not enough air molecules up there to heat you up. Yeah, right. Doesn't quite work like that. The vacuum of space is actually a perfect insulator, which is why we use a vacuum barrier in thermos flasks. The heat from the inside cannot be conducted or convected to the outside. The sun's radiation does not actually heat space up. As I said, the vacuum is a perfect insulator. The sun's radiation traverses space until it hits some object. And when it does, that object absorbs the heat and the temperature rises and keeps rising. And without an atmosphere to conduct or convect the heat away, the temperature will rise up to and over 2,500 degrees. So the Hubble telescope, for instance, would look something like this. All the satellites and the Space Shuttle and the International Space Station, they would all be molten slabs of metal spinning around in orbit. But let's put that aside for a moment. There are supposedly between 25,000 and 50,000 satellites in orbit. But let's have a look at some videos supposedly from the International Space Station. Can you see any one of these 26,000 to 50,000 satellites? I can't. Commands a substantial view over the Earth's surface, and yet you don't see a single satellite. Now, I do accept that you can look up into the night sky and see what we're told are satellites. I've done it myself. I've seen bright lights moving across the sky, but I have no idea what those things are. In this video, you can see several large bright objects. However, none of them appear on any satellite tracking applications. When you look up at a jet airliner flying at 35,000 feet, you can only see it as a small dot. So how is it if something the size of a jumbo jet is rendered as a small dot at about 5 to 7 miles up, that you can see a satellite which is the size of between a car and a school bus at 100 miles away? You just wouldn't see it. At about this point, somebody's bound to say, what about the global positioning system? How would that work without satellites? Well, as it happens, the technology has actually been around since World War II. There are actually two systems, one called LORAN and another called DECA. Those were navigation systems based on radio triangulation. Now, the GPS systems that we're used to now are basically the same systems, just improved with a new computer interface. Similarly, the international telephone traffic that's supposedly handled by satellites are handled by undersea fibre optic cables. Shortwave radio can also span large distances and also be bounced off the ionosphere. So, in the absence of any hard physical evidence, I submit that satellites are just a work of fiction and another way that NASA and the US military managed to con the American public out of billions of dollars.